Okay, we're continuing on page 13 of the booklet, example 1 here. We're finding the gradient of the tangent to the curve, function of x equals x squared, at the point negative 2, 4. So here is my point, negative 2, 4. So what we do, we construct the secant PQ, where Q is a point with coordinates x function of x. Now, yes, Q is x function of x, but function of x is x squared. So Q has coordinates x squared and P has coordinates negative 2, 4. So we have to find the gradient of the tangent by determining the limit as the x value here of Q approaches negative 2 here. So we've got the general form is that x approaches a of the gradient of the secant. So the gradient of the tangent again is the limit as x approaches a of the gradient of the secant. Now we're wanting x to approach negative 2 as Q gets closer and closer to P. X will approach negative 2. So it's the limit as x approaches negative 2. And now the gradient of the secant, we'll call this x2, y2, x1, y1. So it's y2 minus y1, which is x squared minus 4, which you can see here, divided by x minus negative 2, which gives us x plus 2. Now, you've done limits like this before. We can factorize the numerator as x plus 2, x minus 2, because it's a difference of 2 squares, divided by x plus 2. The x plus 2's cancel. I'll just put this one in brackets. And therefore, so we've got the limit as x approaches negative 2 of x minus 2. Substituting x is negative 2 in here, we get negative 2, take away 2 is negative 4. Therefore, as x approaches negative 2, the gradient of the secant approaches negative 4, and therefore the gradient of the tangent is negative 4. Now, if we just have a look, having a look at the graph, we could actually probably work it out. See, the gradient passes through negative 1, 0. So if I go rise 1, 2, 3, 4 and run back 1, if I look here, gradient of the tangent I can see is rise. Sorry, I'll just make some room there. It's rise over run, which is rise 4, run negative 1, which is, if I just do that here, okay, which is negative 4. However, you can't normally do that in this topic. You won't be able to find the gradient of the tangent. It's just that with this particular curve of function of x equals x squared, we can work it out. So however, you can work out the gradient of the tangent by determining limits as the secant, the x value of the secant approaches the point at the tangent. 0.14 and a point on the curve. I'll just put this point here, Q, that is close to, maybe here. And point Q will have coordinates x. It'll have an x value, and its y value is x squared plus 3. Okay, so I've got x squared plus 3, and the 0.14. So the limit as x approaches, now this x value here is going to approach 1 of, so the gradient of the tangent is equal to the limit as x approaches 1. Now we need to do the gradient of the secant of x squared plus 3 minus 4 over x take away 1, x minus 1, which is the limit as x approaches 1, x squared plus 3 minus 4. Well, that's x squared minus 1. So I'm going to write that as x squared minus 1 over x minus 1. We know that we can factorize x squared minus 1 because it's a difference of 2 squares. So x squared minus 1 is x minus 1, x plus 1 divided by x minus 1. So that's the limit as x approaches 1 of x plus 1. Now substituting in x equals 1 into that, we get 1 plus 1, which is 2. So therefore the gradient of the tangent is 2. Now let's just have a look. I can see that this tangent passes through the point 0, 2. So if I rise 2 and run 1, so if I'm just going to check my gradient just by looking at this, the gradient of the tangent is rise over run, which is 2 over 1, which is 2, which happens to be the same. Okay, so I'm just doing that by checking. Often this will not be drawn like that. You won't be able to check it. But we're just showing how this method works. And problem 2 on page 15. So again, just choosing a point Q on the curve close to P. So P has coordinates negative 2, 10. Q will have coordinates x, and this is function of x equals 3x squared minus x minus 4. So the y value will be 3x squared minus x minus 4. So the gradient of the tangent is equal to the limit as x approaches. Now, p has an x value of negative 2. So as x approaches negative 2, now the gradient of the secant, which is the limit as x approaches negative 2 of, now I'll go y2 minus y1, so I've got 3x squared minus x minus 4, take away 10, over, so y2 minus y1 over x2 minus x1, that will be x take away negative 2. So that is the limit as x approaches negative 2 of 3x squared minus x minus 14 over x plus 2. So it's the limit as x approaches negative 2, factorising. We should probably have an x plus 2. Let's have a look. So we've got 3x squared plus 6 or plus 6x minus 7x minus 14. Okay, so we want two numbers that multiply, two terms that multiply to give 3x squared, and two numbers that multiply to give negative 14. So we've got negative 7 and 2, so we've got 3x squared plus 6x minus 7x minus 14 over x plus 2. Cancelling, it's the limit as x approaches negative 2 of 3x minus 7, which is, substituting in negative 2 there, we've got 3 times negative 2, take away 7, that's negative 13. So the gradient of that tangent is negative 13. Okay? Now, don't think we can work that one out on the graph, it's too hard. Okay? The tangent is the limit as x approaches, our point on the curve is 3, 0. So as x approaches 3 of the gradient of the secant. So it's the limit as x approaches 3. Now the gradient of the secant is, so our points are, I'm just going to write them up here. P is 3, 0, and the other point Q is x and 3x squared minus x cubed. So our gradient is 3x squared minus x cubed minus 0 over x minus 3, which is the limit as x approaches 3 of, just going to factorise this numerator, so x squared bracket 3 minus x over x minus 3. Now, we can see we've got the, what I'm going to do is pull out a negative here on the numerator, so it's the limit as x approaches 3 of negative x squared times x minus 3, because that's negative x plus 3, which is 3 minus x over x minus 3. We can cancel our x minus 3's, and we've got the limit as x approaches 3 of negative x squared, and substituting x is 3, we get negative 3 squared. Now the negative is not squared, it's just the 3 that's squared, so we've got negative 9. Now we can see that the gradient of this line is negative, and it's very, very steep. Okay, so that would make sense that the gradient is negative 9. Page 17, the last one in this video, we've got that the gradient of the tangent is equal to the limit as x approaches 1. Now I'm just going to put a point here, Q, on the curve, very close to P, and it's going to have coordinates x, and function of x will be root x. So it's the limit as x approaches 1 of, now this is x2, y2, x1, y1, of square root of x minus 1 over x minus 1. So that's the limit as x approaches 1. Now I can write the denominator as a difference of two squares. I can write it as square root of x squared minus 1 squared. Now I can factorise the denominator, and I'll get the limit as x approaches 1 of root x minus 1 over root x minus 1 times root x plus 1. And now cancelling, I've got the limit as x approaches 1 of 1 over the square root of x plus 1. So it's 1 over the square root of 1 plus 1, which is 1 over 1 plus 1, or a half. Okay, so therefore the gradient of this tangent here is a half. Okay, all right, and that looks about right. If that's the point 1, 2, I think this is the point, it's a bit hard to tell, 2, 3, actually it is, on that tangent. So rise is 1, run is 2. Okay, so if I just look at that, the gradient of the tangent not that you would normally do this, using rise over run, is 1 over 2, which is a half, which happens to be the same answer as we get here using gradient of tangent is limit as this x approaches the x value here at the tangent, okay, of the gradient of the secant.